Welcome to Study Loop.
So in this problem, we are given a reaction equation of this Na2O, which is a solid reacting with SO2 or sulfur dioxide in gaseous condition to form sodium sulfate, which is again a solid. So we are asked to find out the equilibrium constant in terms of pressure for this reaction. So as we know that the equilibrium constant in terms of pressure is basically um, contain the partial pressure of the products as the numerator and the partial pressure of the reactants in the d- denominator. So, but in this case, you can see that since our product is a pure solid, and we know that pure solids are not included in the equilibrium constant expressions because we consider that there is no significant change in their concentration, or in other words, their concentration remains constant throughout the reaction equilibrium. That's why we do not include pure solids or pure liquids in the equilibrium constant expressions. That means here as a numerator we will have to write 1 since we don't have any partial pressure expression for the product. And in the reactant, also we have one of the reactants as solid. That means we will not include this one also in our equilibrium constant expression. And the other reactant here is sulfur dioxide, which is a gas, and this will be included in our equilibrium constant expression, which will be PSO2. So for this reaction, this is the equilibrium constant expression in terms of pressure. Now, in part B of this question, we are asked if all the compounds in this reaction are soluble in water, then we'll have to rewrite the equilibrium constant. So if all of them are soluble, then we will write down the reaction equation as Na2O. We'll write it as aqueous since soluble means they're in aqueous form. And then SO2 will also be in aqueous form, and they will give us Na2SO3, which is also aqueous since all of them are soluble. And now in this case, we don't have any pure solid or pure liquid here. That means the equilibrium constant expression, in this case, we have to write it in terms of molarity. That means it will be Kc. So the value of the Kc here will be the concentration of the product over the multiplication of the concentration of the reactants. So this is the equilibrium constant in terms of molarity for the reaction if all of the compounds in this reaction are soluble.